and welcome back to neurobiology in 5 minutes or less. In this video, we're going to talk a little about myosin movement and how these thick filaments and these thin filaments actually move to create this muscle contraction that we see. So the very first thing to keep in mind is that the actin filaments do not move. The actin filaments are stationary and act almost like a rope. And that'll be really helpful thinking of yourself climbing this rope. So if you, in this scenario, are the myosin, or this photo, the green, and the rope is the actin, or this tan filament. So the first thing that needs to happen in order for you to even consider climbing the rope is we have to see this myosin dissociation from actin. And so basically, before we do anything, right, this myosin, like, you are grabbing onto the rope, right, because you're getting ready, but you haven't thought about climbing yet. So you're just kind of chilling there, you're waiting for somebody to tell you to go. And as soon as they tell you to go, then you're gonna try and get that jump off onto the rope. So you're gonna try and get your best starting position. So the very first thing that happens is the ATP comes in and it binds to our myosin head. This right here, this is our myosin head. And so whenever you're thinking about it, this part is the myosin filament, this part right here, and this part is our myosin head. So the myosin head and the ATP are associated together. This is the part of the actin filament that they were bound to, and then once the ATP binds to the myosin head, they're no longer attached. The second thing that happens is our ATP hydrolysis. The ATP hydrolysis actually is the part where you move. So before we were here, and then this flips. You can see the orientation change from photo 1 to photo 2, how it's changed from the head being more towards the left to now it is more towards the right. And that is what the ATP hydrolysis did, was that orientation flip. Now we have an ADP over here. So the ADP is going to have the myosin, because now you've depleted your energy, right? In climbing this rope, you did this flip, you're doing really great, but now you need to hold on to the rope again because you're tired, because you don't have ATP, which is your energy. So then we see, look, now it started on this first circle. Now we've moved to this second circle, right? So there is a movement there, which is awesome. But it's not, and it moved, but right now we're still in the orientation flip. And then what's going to happen is we're going to, that ADP, now that we are stable and on that rope again, your ADP is going to leave. And when it leaves, you have that conformational change. That conformational change back to that original position. And once again, the myosin head is facing left, right? And so if this were to start again, if we were to go through this whole cycle again, when we would end up, you would have it being the exact same conformational change like this, but we would be on this circle now. And then the next time this, and then this, and going on and on and on and on and on. So it's really interesting to see how this works, because this is the way that your myosin head literally claws down this actin. And you can think of this because think about how instant a muscle contraction is. Just in this video alone, every minute I'm talking, I am contracting muscles, both for breathing, for my heart, for any movements that I'm doing, all of my vocal cords and my mouth, my jaw, all these things that are constantly contracting and relaxing, contracting and relaxing. And this is the process that needs to happen to move it down just one part of the filament. And if you could remember back to that first photo, there's a lot of space that it needs to cover. Yeah, this power stroke, this flip is key though, because that really helps shrink that space. Because before, even though we had done a lot of changes, we hadn't really moved our filament at all. We hadn't really moved the filament, and that part we did. So that power stroke is an essential part of this process. So I hope after watching this, you understand the movement of myosin a little bit better.